Percent composition. We've talked about percent before. Percent means parts per 100 parts. Percent per 100. There's 100 cents in a dollar, right? Another way to define percent is this way. The part over the whole times 100. End up with exactly the same thing. But this way of thinking of percentages is useful when we talk about percent composition of a compound. Percent composition tells us the percentage of each element by mass in the compound. And like density, percent composition is the same regardless of the amount of compound. So if you have a little bit, the percent composition is the same. If you have a whole bunch of it, the percent composition is the same, because it's relative to the size. So part over whole times 100. So let's calculate the percent composition of water. We can do this from the chemical formula. So H2O is the formula. Percent composition, we're looking for percent hydrogen and percent oxygen, the two elements that are in it. The percent hydrogen will equal the mass of hydrogen divided by the mass of the whole thing, the water, times 100%. This is another example of a problem without any numbers in it. Problems with lots of numbers bother students. Problems with no numbers bother students. The sample size doesn't matter. We just need to pick something. What might be a convenient sample size? How about a mole? 1 mole. Could we find the mass of 1 mole? Yeah, the mass of 1 mole. So we're just going to choose 1 mole. You can do it other ways if you want, but this is what I recommend. Choose 1 mole. So then we can find the mass of 1 mole of water. It's the molar mass. 18.02 grams is equal to 1 mole. So here in the equation then, the mass of water is going to be 18.02 grams. What's the mass of hydrogen in 1 mole? It's this part right here. It's that much hydrogen plus this much oxygen. So this is the mass of the hydrogen, right? That's 2.016 grams is the hydrogen. So I'm going to put that up here, 2.016 grams. And then we have to multiply by 100. 2.016 divided by 18.02 times 100. I get 11.2% hydrogen. Actually, I shouldn't round that to 3 significant figures. I should keep 4. 11.19% hydrogen. Any questions? How do I find the percent oxygen? I could subtract from 100, or I could take 16 and divide by 18.02 times 100. But since there's only 2, we know that all the percentages have to add up to 100, because that's the total. So 100%, and that's an exact number, minus 11.19% for the hydrogen, gives us 88.81% for the oxygen. There's only 2 components. So if we calculate one, we can subtract the other from 100. Any questions? EDTA. You might have seen that on food labels. It stands for ethylene diamine tetraacetic acid. It's used as a food preservative. It's also useful in the treatment of lead poisoning. Calculate the percent composition of EDTA. Well, this one's a little more complicated, isn't it? So we have 4 different elements here. Here's the formula that's given to us, C10H16N2O8. We're going to need the molar mass, and we might as well write it all out because that's actually going to help us to do the percentages. So we choose 1 mole because it's convenient, and we're going to find the mass of the whole thing, which is the molar mass. So I've got 10 times the mass of carbon plus 16 times the mass of hydrogen plus 2 times the mass of nitrogen plus 8 times the mass of oxygen. 10 times 12.01 plus 16 times 1.008 plus 2 times 14.02 plus 8 times 16, 292.268 grams. And as I did it, that would have 4 sig figs. That's the mass of the whole thing. So if I'm looking at percent carbon, I'm looking at grams of carbon divided by grams of the whole thing, C10H16N2O8. There's a reason they call it EDTA, even its chemical formula is too long. So 292.268 grams down here. The mass of carbon is right here. So that's the grams of carbon. This is grams of hydrogen. This is grams of nitrogen. And there's the oxygen. Um, 10 times 12.01 is going to be 120.1 grams times 100. 120.1 divided by 292.268 times 100. This will have 4 sig figs, so 41.09% carbon. How would I find the percent hydrogen? I take this and divide it by this same number times 100. And for the percent nitrogen, 2 times 14.02 divided by the whole times 100. And then for the last one, I could either do that same thing, this divided by that, or I could take 100 and subtract all the others. This time it might be easier to just calculate it using the equation. I'm not going to go through all of that, but any questions about calculating percent composition?